guys, welcome to question MM436 of the Maths Methods Fortify study guide. So in this question we've got this continuous random variable x which has a probability density function of e of x between 0 and log e of 2. Now given that the derivative of x e to the power of x equals x plus 1 times e to the x, find e to the x, or e of x. Awesome. So as always guys, with probability density functions, our e of x, or our mean, is equal to our integral from our lower to our upper of x times f of x dx. So in this case, our e of x is equal to our integral from 0 log e of 2 of x times e to the power of x dx, right? Now, we don't know how to integrate this, right? We don't know how to antiderive x e to the power of x in methods. So what we actually have to do is use a system or function called integration by recognition, okay? So we've got this piece of information here. Now what this means is that if the derivative of this is this, that means the antiderivative of this is this, okay? So that's where we're going to start with this, and you'll see where I'm going with this if you're not too sure how to do this. So the integral of x plus 1 times e to the x equals x times e to the x, right? I'm just going to expand this out just so that I can explain the next part. So we're going to expand this to x e to the power of x plus e to the power of x dx. So that equals x e to the power of x. Now what we're looking for is the integral of x e to the power of x, which we've got here, right? X e to the power of x. Actually, also just before I go on, that's your first mark there, recognizing that. We're looking for the integral of x e to the power of x, which is here, right? We've just got to separate this from everything else and then we can use it in our own equations. So just leaving this as it is, x e to the power of x. Now I'm going to separate these two integrals. So we get x e to the power of x dx plus e to the power of x dx. So this is the same thing, I've just separated them into two, and that's equal to x e to the power of x, okay? Now, from here we can say that the integral of x e to the power of x dx is equal to x e to the x minus the integral of e to the power of x dx. Okay, so I've just taken this integral here and I've minused it to the other side. Now what this means is we can say that the integral of x e to the power of x dx is equal to x e to the x minus the integral of e to the x, which is simply e to the x. Okay, so now we've actually found what this is, right? We've found the integral of x e to the x. It's this one, which means that our integral from 0 to log e of 2 of x e to the x dx, which is exactly this bit here, equals our integral, which is x e to the power of x minus e to the x, from 0 to log e of 2. This is our second mark. Awesome. So now all we have to do is actually just sub these in as normal, and then we'll get our answer. So from here we can say that's equal to, we can sub in our values. So we can say x is log e of 2 times e to the power of log e of 2. Take away e to the power of log e of 2. That's our first bit there. So that's the first bit. And then we minus our second bit, which is 0 in place of x. So 0 times e to the power of 0 minus e to the power of 0. Awesome. So e to the power of log e of 2, the e and the log e actually cancel and we end up with just a 2 on this level. So this is actually just a 2 here. So we get log e of 2 times 2, which is 2 log e of 2, minus e to the power of log e of 2. Again, e to the power of log e of 2 is just 2. So we take away 2, then we've got this minus e to the power of 0. Oh, we got this 0 here, that can cancel because that's just a 0. And then e to the power of 0 is 1, so we get minus negative 1, which is plus 1. So we get 2 log e of 2 minus 1. And that's our e to the x. This is our third and final mark for MM436, guys. I know this is confusing. Any of this integration by recognition stuff, let me know if you're not too sure about it, and I'll answer any questions that you've got. But otherwise, thank you very much for watching, as always, and I will see you in the next video.